In this video, we'll be talking about IR and UV-VIS. For UV-VIS, we have the Beer-Lambert Law, or Beer's Law, which is this equation here. There are four variables. The first variable is going to be absorbance. The second variable is going to be the molar absorptivity. B is going to be the path length. And C is going to be concentration. For the unit, concentration is going to be in molarity. Path length will be centimeters. Molar absorptivity will be inverse molarity and inverse centimeters. This means that absorbance is actually going to be unitless. The next question asks, what is redshift, and to describe the significance in UV-VIS. So for UV-VIS, a redshift is caused by conjugated double bonds that decrease the energy of a molecule, which in turn increases the max wavelength. So we know that conjugated systems are going to be more stable than isolated systems. So this makes sense that we will get a decrease in energy. For the increase in wavelength, if you look at an electromagnetic spectrum for visible light, the red light is going to be closer to radio waves, which have very long wavelengths and little energy. And on the other side of the visible light, you have purple light, which is going to be closer to gamma and X-rays, which are higher in energy, but have shorter wavelengths. Here, we have an IR spectrum, and we need to match it to one of the 5 compounds. So the first peak that I would look for is this one here. Now this may look like a carbonyl peak, but it's not, because it is not your strongest peak, and it's a little bit too wide. So since we don't have a carbonyl peak, we can eliminate 2 of the compounds. And if we look closer at this peak, this is going to be a carbon-carbon double bond. That means we can eliminate the first compound. For this peak here, this is going to be sp2 and sp3 peaks. So this is not going to correspond with this compound here because there is no OH peak. That leaves ethyl vinyl ether as the correct answer. For the next IR spectrum, we have to do the same thing. For the spectrum, we have an OH peak. And for this peak here, this is going to be another carbon double bond peak. Again, this will not be a carbonyl peak because it is not strong enough. We are going to ignore the fingerprint region. So looking at the answers, we have this compound that has both a double bond and an OH group. For the last one, we are again going to ignore the fingerprint region. And we have a very similar spectrum from the last question. Again, we have an OH peak, and this peak here is going to be the carbon double bond. So the answer is going to be this compound here. That concludes the video on IR and UV-VIS.